we talked about the how to make ionic compounds with the group 1A and the group 7A. Now we are doing the group 1A elements and group 6A elements. All right. So you can, if you can see, let me put it in the larger version of this on my screen. Let me share the screen. I think I'm not sharing the screen yet with you. Let me share the screen. Share the application screen. All right. And let's see the hide here. And put it like this. And everybody can see it. If you do not, please let me know, okay? All right. And I did some practice, I'm positive, during the weekend, I guess. So group 2A elements, right? When n equal to, let's go a little bit back. All right. So group 1A elements, that's a sodium, potassium, lithium, etc., right? And if you have a sodium is 1 plus, right? That's what we did. Na 1 plus, group 1A. And oxygen is 2 minus, right? Because oxygen is group 6, 8 minus 6 is 2. And if you put it together, just 1 second, put it together, and you need 2 Na, right? Why you need 2 Na? Because you have 2 minus and 1 plus. So you have to add 2. 2 Na plus, Na is 1 plus, so 2 times Na, 2 of them, and O. So that's a sodium oxide. Sodium oxide. Likewise, if you do the potassium, same thing, potassium sulfide, do the same thing, K2S, lithium, Li2O, lithium oxide. No question, right? Everybody okay so far? So that's a group 1A and 6A elements. Now, if you have group 1A, 7A elements, that's 5A elements, 5A means 8 minus 5, so 3. They make 3 charges, right? So example is lithium. Lithium is group 1A, so lithium 1 plus, and nitrogen is group 3 and group 5A, and it makes it 8 minus 5, 3 minus, right? And if you add them together, you have 3 minuses, 1 plus, so you need 3 of these guys. So therefore, you have a
Professor Dada.
Yeah.
I think last Friday we stopped at like properties of metals, so I don't think we actually got this far. So it's kind of confusing.
I think we go to the. I think we talked about the.
No, we got to the properties of metals.
Give me 1 second. Properties of. Oh, we just we are way right here. Are you sure?
Yeah.
Okay.
Yeah.
All right. Oh, okay. I went a little too far then. I'm sorry. All right. Very good. Thanks for reminding me. All right. So this is the everybody okay with so far this one, right? So metal properties of metals is a metal donates electron and become cations. And group 1A metal will lose 1 electrons to become 1 plus. Group 2A metal will lose 2 electrons, will be 2 plus. And group 3A metals will lose 3 electrons and become 3 plus. So everybody okay, right? So number of electrons lost or positive charges corresponds to the position in the periodic table, which is represented as N plus. So when is the group 1, 1 plus, group 2, 2 plus, group 3, 3 plus. So basically lithium, sodium, potassium, rubidium, they all become a 1 plus. So everybody okay, right? Likewise, if you do the group 2 elements like magnesium, calcium, barium, strontium, they'll become group 2, so 2 plus. Group 3 elements, aluminum, gallium, will become 3 plus. All right. And why they are doing it? They are following the octet rule. So 8 electrons in the valence shell. As you will see very soon, I'll show you within a minute that once the group 1A, 2A, 3A metals lose electrons, appropriate number of electrons, the outer inner shell becomes stable because they have an inert gas configuration, and they have 8 electrons. 2s usually S has 2, P has 6, 2 plus 6, 8 electrons, and that's basically they're stable. But by default, they make a positive ion. An exception is hydrogen. Transition metals, inner transition metals like lanthanides, actinides, they don't follow rules probably. And hydrogen, as you probably know, it has only 1 electrons anyway. So these are the exceptions. So that's the properties of the metals. properties of the non-metals, very similar, but exactly opposite of the metals. Non-metals accept electron or gain electron to become anions. Anions means a negative charged particle. Negative charge ions, anions. So anions, remember, group 3A, group 5A, 6A, and 7A, those are pure non-metals. Group 4A is also non-metals, but it doesn't lose electrons or gain electrons, because we'll talk about that on the carbon compounds, and we'll go say lot of information there to talk about how the carbon makes the compound with many other elements. So group 5A, 6A, 7A, those are non-metals. They accept electrons and become anions. How many electrons they gain? That depends on the position in the periodic table. And they also follow the octet rule. So 8 octet is octet, the 8 rule, 8, right? 8 electrons in the outer shell. And that's a, 8 electrons in the outer shell. And so 8 minus group number in the periodic table that represents n minus, n minus. So for example, if you have a 7A elements, give me a second, please. My cursor is still, all right. So group 7A elements, for example, so if you have group 7A, for example, the halogens, you have a fluorine, right? Fluorine, chlorine, bromine, they're all group 7A elements, right? And iodine, for example, these are the halogens. And the group 8A, the group 7A, so 8 minus 7A, they'll become 1 electrons, and will become F minus, 1 minus, right? N minus, 1 minus, Cl minus, Br, bromine, Br minus, and I minus, 1 minus. Because 8 minus 7 is 1, therefore we'll take 1 electron. So that's basically the number represents. Likewise, if you have a, let's say, oxygen, sulfur, right? These are group 6A elements, and they have a 6 electrons in the outer shell. So 8 minus 6, they'll take 2 electrons. So oxygen will become O2 minus, right? Likewise, sulfur is group 6 also. Sulfur will take 2 electrons and become 2 minus, right? You already did that. So now, group 5A includes the nitrogen, phosphorus. They have 5 electrons in the outer shell. So 8 minus 5, they will take 3 electrons, will become 3 minus. So N3 minus, N3 minus. Likewise, phosphorus is also group 5A. So 8 minus 5 is 3. That means phosphorus will also become, just like a nitrogen, will become P3 minus. All right, so that's basically that's anions. These are all anions, because these are our non-metals, except electrons, and they're following the octet rule. There are some exceptions, specifically the phosphorus and sulfur. They can have more than 8 electrons in outer shell. And we'll give some example down the road. All right. So let's see. So cations, once you have a cations, metals lose electrons to become cations. Non-metals gain electrons to become anion. And cation anions do not acceptor and become ionic compounds. So that's the basic principle of making ionic compounds. Basic principle of making ionic compounds. Metals lose electron to become cations. Anions gain those electrons to become anion, and positive charge, negative charge, they attract. They make the ionic compounds. One such example, sodium, for example. A sodium atom has 8 electrons in the outer shell, 8 electrons altogether, 8 protons and 8 electrons, and that will lose 1 electron. It's a group 1A, right? Therefore, sodium will become sodium plus, and that electron is lost. And that electron, and why it is lost? Because if you look at the electronic configuration of sodium, 1s2, 2s2, 2p6, 3s1. The outer shell electrons is only 1, and that's the electron lost, and that's its group 1A. And once it loses this electron, look at the inner cell. Inner cell has a 2s2, 2p6. 2 plus 6 is 8. That's octet rule. And 1s2, 2s2, 2p6 is a configuration of neon, right? That's a configuration of neon. If you look at the neon configuration, so it is the inert gas configuration. It is stabilized, but by default it's a positive charge. Why? Because it has a 11 protons in the nucleus, 11 electrons in the outer shell. 1 electron is gone. 11 protons still remaining. therefore net charge, and only 10 electrons now. So therefore residual charge is 1 plus. So that's why 1 plus. So now similarly, so if you get anion, let's say if you take a non-metal like a chlorine is group 7a, and it is a 8 minus 7. It also follows the octet rule, and it is 7. So 7 means 8 minus 7 is 1 electrons. Chlorine will accept that electrons that sodium lost, and it becomes Cl minus. And if you look at the electronic configuration of chlorine, 17 electrons, 17 protons in the nucleus, right? And 17 electrons are distributed 1s2, 2s2, 2p6, 3s2, and 3p5. So outer shell has 2 plus 5, 7 electrons. Once it accepts 1 electrons or gain electrons, then it becomes 6, right? So therefore, the outer shell will become 3s2, 3p6, and that's also 8 electrons. Octet rule. That's basically they take the electron. Now, and once it becomes 8 electrons, it becomes the configuration become argon. Argon is the inert gas, right? Argon is configuration argon. So it is stabilized, but by default, it became an anion because it accepted 1 electrons. It has 17 protons in the nucleus, 17 electrons in the outer shell, so it is neutral. Once it accepts electrons, it becomes 18 electrons, but proton number remains the same. It's in the nucleus, it's not changing. So 17 plus 18 minus, residual charge is 1 minus. So that's why Cl minus. And therefore, since a sodium lost the electron, chlorine accepted that electron or gained that electron, so Na plus plus Cl minus, now you're making the sodium chloride. So that's the fundamental basis of making ionic compounds. Now we'll go to a little bit generalized version. We'll go a little bit more details of those things, right? So now if we go to the group 1A metals, first thing we'll give the name of the cations. How do you name the cations? That's a first thing. So cations are named. So group 1A, group 2A.
Are you able to go back to the last slide for 1 second?
Sure, absolutely. So once again, so this is the fundamental basis, and please remember that this is the basic principle of making ionic compounds. Metals lose electrons, non-metals gain metals lose electrons, become cations, positive charge. Non-metals gain electrons, become anion. And why do they lose or gain? Because they want to stabilize their inner core, and that's our inert gas configuration. And that's basically they lose or gain electrons. Okay. All right. Can I move on to the next?
Yes.
All right. So if we can go generalize now, group 1A are the metals. Therefore, not the hydrogen. Hydrogen belongs to the gas, but it behaves very similar like a metals. That's a group 1A. So except in hydrogen, but in terms of the group 4 elements, hydrogen can lose 1 electrons, become H hydrogen ion or proton. Lithium can lose electrons, lithium ion. Sodium lose 1 electrons, group 1A. Potassium lose 1 electron, become 1 plus each, right? And how do you name them? Basically, name of the element and then just add the ion. But now, this ion that you must know the group 1A, group 2A, group 3A, they are metals. That means this ion is a positive charge ions. It is not said though, but you have to remember that, right? So group 1A, positive charges, group 2A, these are metals, lose electrons. So if you go to group 2A, exactly the same way. Magnesium 2 plus, magnesium ion, calcium 2 plus, calcium ion, strontium 2 plus, strontium ion, barium 2 plus, barium ion. So basically the name of the metal and the ion. And the charges, the positive charges corresponds to the group number. 2A, 2 pluses. 3A, you have 3 pluses. Aluminum ion, aluminum 3 plus. Likewise, you can write another one. Let's say Ga, gallium. Gallium is also a 3 plus. So gallium, and same way, you just add the gallium, the name of the metal, gallium, and ion. That's basically it is. Likewise, if you go to another one, indium, In is also indium. That's a group 3A. And that is also metal. It will make a 3 plus ion, gallium, indium ion. So that's basically the commonalities. And if you go to the non-metals now, very similar. So before you go to the non-metals, then we will go to the transition metals. The transition metals also make some ions. But many of them, they don't follow the octet rule though. But we need to know some of them which are common to our daily routine, basically. And it is some of the metals are also present in our body, all living creatures, and therefore we'll go some transition metals, not all of them, which are very common. And these are the transition metals. So how to name those transition metals? For example, copper plus and copper 2 plus. Copper is a Q plus ion. It can make one positive or two positive. And as you probably remember, copper ions 2 plus or 1 plus, it is present in the mitochondria, specifically our powerhouse. And because of the copper plus, copper 2 plus, the conversion, it can accept electron or gain, it can lose electrons or gain electrons. And therefore, and that electron could be passed to the oxygen to become water, So that's happening in the mitochondria. So copper ion, copper 2 plus ion is a physiological ion. It is present in the mitochondria, and all eukaryotes need these 2 ions specifically for our respiration, all right? And therefore they are important. How do you name them? Copper is a transition metal. It can have a 1 plus called copper parenthesis 1 plus ion. Copper 2 plus, copper parenthesis 2 ion. It is also another common name called Q plus, OUS, or IC. So lower valence, like a 1 plus, AS, OUS. Higher valence, 2 plus, IC, Q prick. So Q plus, lower valent, Q prick, higher valent. So this is a very common name, not routinely used, but these are very common. Copper 1, copper 2. That indicates that how many charges are there and why they are so important. Because transition metals are weird. They basically don't behave proper rules, and therefore it is better to know that. But this convention is also used routinely as well. Q plus ion, Q prick ion. Similarly, we can go to the iron, another transition metal, and as you probably know, Fe2 plus and Fe3 plus, you can have 2 different charges. Fe2 plus color is blue. So when our RBC, red blood cells, gives the oxygen to the cells, it is become deoxygenated blood. That's a blue color. And that blue color, and that is coming through the vein. If you look at your vein in front of your hand, leg, anywhere you can see blue lines, and those are the veins carrying the Fe2 plus deoxygenated blood to the lungs. Once it will be oxygenated, it will become converted to 3 plus. And 3 plus is deep red. You don't see, those are arteries are carrying those blood. So iron 2 plus, iron 2 ion, iron 3 plus, iron 3 ion, or you can also use the common name AS and IC, ferrous ion and ferric ion. As you probably recall, if you see in your dent of your car, old car, which are made with iron, there's some bumper or anything, and usually when you hit the dent at the beginning, you see usually yellowish color. Yellowish color corresponds to Fe2 plus. It is bluish, it ultimately convert to the yellowish, and then as it goes on and on, that bumper is not fixed probably, and then it can see the deep brown color, and that's a ferric 3 plus. Ferric 3 plus. But our blood system is pretty example, is a very vivid example that one can see the blue color versus the red color. All right, so that's the ferric ion and ferrous ion. These 4 ions that we have seen, the mercury plus and mercury 2 plus, it is not present in our body, but you should know in the sense, because mercury is being used as in the thermometers, and so mercury as it is, not as atomic state, not like a ionic state. So mercury can also have the same thing, Hg plus, mercurous ion, Hg2 plus, mercuric ion. Stannous 2 plus, stannous 4 plus is not important in our cells, in our body, but just for the sake of simplicity, write a T2 plus and T4 plus. So stannous ion and stannic ion. So once again, the nonmetals, when have a lower valence called AS and higher valence IC. So that's a convention. So if you want to make any compound with a mercury or something like that, and that basically we are up to this one. All right, so these are transition metals. You don't have to write this column. These are just names are coming from the Latin words, and it's not that much important. But definitely you should know those where did they come from. As we said, the metals came from many different sources, planets, different worlds, different countries, etc., etc. They're named differently. All right, I'm going to move on to the non-metals now. If you do not have any questions, so non-metals will also, non-metals they accept electrons, right? And they basically become anions. So how do you name them? Usually naming is very simple. I mean, simple in the sense is for example, group 7A, fluorine, chlorine, bromine, iodine, they can accept one electrons, 1 minus, 1 minus, 1 minus, 1 minus, right? So how to name them? Fluorine, remember fluorine is Fluorine, fluorine, but it is ion now. So use the root word, that's a stem words, the stem name, fluorine, fluoro, IDE, add the IDE, fluoride. Same thing, chlorine, chloro, chloride, chloride, chloride. Brom, bromide, bromine, right? Bromine, brom, IDE, bromide. Iodine, iode, IDE, iodide. Oxygen, GN, right? Oxygen. And if you have the ion, so group 2A, these are group 2A guys, and oxide, IDE. Sulfur, sulfide. So that's basically the naming of the anions. Now, once you make the compound, the cation and anion, then basically you will take the ion from the metal off, and then you make the IDE of the root word. For example, sodium is sodium plus is sodium ion, chloride, Cl minus is chloride ion. Then we'll take those ions off, we'll make a sodium chloride. Well, those ions are gone now, make a compound, neutral compound. Sodium bromide, potassium iodide, lithium oxide, etc., etc. All right, so these are the naming of the those the anions, naming of the anions. So naming of the cations, naming of the anions. Now we'll make some compounds. Now we'll make them. Before we go to that anions and cation, I must give you this one as well. The polyatomic.
Can you go back for a quick second?
Sure.
Thank you.
Sure. You're welcome. So fluoride, chloride, bromide, iodide. These are all basically coming from our group 7A. You can also have a, I did not give you this one, you can have a N3 minus, P3 minus. So name of this one will be nitrogen, right? So basically nitrogen is nitrogen, so nitride, IDE, that's I, huh? Nitride, NITRIDE, nitride. Similarly, you can name this one also phosphorus, right? So phosphorus, PHA, phosphide, IDE, phosphide. So nitride, these are the 7, right? These are 5 elements, right? So 5. Other one is arsenide, AS, arsenide. So nitride, phosphide, and so on and so forth. Can I move on?
Yeah, thank you.
Thank you. Now, so as I said earlier, so this anions and cations that I gave you, those are from pure our periodic table. There are some ions which are combination of two or more elements, and they make ions, and those are called, we call those polyatomic anions. So polyatomic ions. Polyatomic ions could be cation, polyatomic cation, or polyatomic anions. There is only one polyatomic cation, and you must remember that this is ammonium ion, NH4 plus. And how does it happen? Remember ammonia, nitrogen has a pair of lone pair, and it make a bond which has 3 unpaired electrons, right? And make a bond like this way, and it makes the ammonia, NH3. Remember 3 pair, right? You have one electron from nitrogen, 1 electron from hydrogen, and therefore they make a bond, and 1 lone pair stays. Now, this lone pair routinely, usually, is not being used as a molecule as it is, but when needed, for example, if you have a proton, let's say H plus. Now, this hydrogen doesn't have any electron at all. It has only 1 proton. So if he wants to make a bond, usually it does. Now the lone pairs will make a bond and neutralize the charge. These 2 electrons making a bond, and that will become NH, plus ammonia as it is, and then another bond made by the lone pairs. Unusual, very not usual, but that's why now you have 4 bonds, and now the positive charge, because the nitrogen gave the 2 electrons itself, It did not, and proton H plus did not give any electron whatsoever. So the nitrogen will become positive charge, and that is our NH4 positive, ammonium ion, ammonium ion, ammonium ion. That is the only cation, polyatomic cation, by the way. So you must remember that, right? When you make the compound, there are several polyatomic anions, that includes the hydroxide ion. So you must remember the hydroxide ion. Oxygen is 2 plus, 2 minus, group 6. Hydrogen is 1 plus. If you add them together, it's 1 minus remaining residual, and that is our OH minus, hydroxide ion. This hydroxide ion came from the bases, like a sodium hydroxide, potassium hydroxide, lithium hydroxide, and we'll talk about those acids and bases. Most of the polyatomic anions that you see here, they generated from the acids. OH minus is the only one came from bases. Acids and bases we'll talk about down the road, right? So OH minus is called hydroxide ion. Nitrous NaH, so NO2 minus is called nitride ion, and it came from nitrous acid HNO2. HNO2 is called nitrous acid, nitrous, NiTROUS acid. And if we take the proton off, one minus remaining. So that's the nitride ion. Nitride ion is very, very dangerous to us. You can say why? Or sometimes some of the frozen food, no offense to anyone, if someone eats a frozen food, too much of it, they consume quite a bit of sodium nitrous or nitrous acid. So many companies, they put a sodium nitride, NaNO2, as a preservatives. And once it goes to our gut or stomach, with the help of HCl, it makes a nitrous acid. Nitrous acid, and it goes inside the nucleus, and it makes some, it makes some the mutation to DNA, RNA, and proteins. So that could be bad. So therefore, nitride ion, you should remember that, right? NO2 minus. Nitrite, as you can see, NiTrite, nitrite. The higher valent, that's the lower valent, because it came from nitrous acid. HNO2 is a nitric acid. HNO3 is a higher valent of the nitrogen, is nitric acid. If you take the proton off, you get the nitrate, NO3 minus, called nitrate ion. So they all come from the acids, and you must remember that, right? Nitric acid gives a nitrate. Acetic acid, which is vinegar, if you add a 1 proton there, CH3, COO minus, and H plus proton. If you take the proton off, it becomes minus. That's called acetate ion. It came from acetic acid. This is the organic, this is the carbon molecular compound. We'll talk about down the road later on, but just remember acetic acid because it has some applications in our daily lives. And vinegar, sometimes you use it, right? Vinegar is also used for the preservatives. Vinegar also used for cooking. So that's why just you should know the acetate ion as well. Cyanide, Cn minus. The cyanide comes from hydrocyanic acid, HCN. HCN is very bad, very, very lethal. Tell me, if you have a little bit, if someone has a little bit of cyanide on the blood, what will happen? The person will be killed, will be dead, right? Because what it does, it binds the iron 2 plus and 3 plus, and and then hemoglobin, the red blood cell cannot get the oxygen anymore. Cyanide is very, very poisonous ion, very, 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 very poisonous in the form of potassium cyanide, sodium cyanide, or hydrocyanic acid, HCN, whatever it is. The Cn minus is very, very dangerous to our health. So you must remember that as well. This one not that much important, but we can, I just give you anyway. The next one you should know, carbonate ion, CO3 2 minus, and it came from carbonic acid, which is H2CO3, carbonic acid. If you take the 2 protons, these 2 protons off, you get a CO3 2 minus. So it's a carbonic acid, H2CO3, give the carbonate ion. Likewise, if you come to this side, And if you one hydrogen, the two hydrogens are gone because CO3 minus, 2 minus. If your one hydrogen is removed as H plus, then HCO3 minus. And it is also important because it is a bicarbonate. And bicarbonate is routinely used for cooking, for baking the dough. You making honey, you make the dough to make a pizza or something like that, or some other purposes, or bread. They use the sodium bicarbonate. People used to use the sodium bicarbonate to neutralize the acid. If someone has acid problem in the stomach, acid reflux, it is dangerous in the sense because it releases sodium hydroxide, and which can make some ulcer to the stomach. But sodium bicarbonate has some use. So you should know hydrogen bicarbonate, HCO3 minus. It's called hydrogen bicarbonate, hydrogen carbonate, or bicarbonate is the trade name, routine name. The last one, sulfide, is not that important, but definitely you must remember this, sulfate. Sulfate is very important, and it came from our H2. The acid is called H2SO4. H2SO4. Does anyone know what the H2SO4 stand for? H2SO4? Anyone? H2SO4 is a sulfuric acid. Sulfuric acid. Sulfuric acid. Very, very strong acid. H2SO4. If you take the two protons off, you get SO2 minus, SO4 2 minus, and sulfate ion. Sulfate ion. Likewise, if you take one, it is two hydrogen. If you remove only one hydrogen, then you can get one hydrogen still there. Then it will be HSO4 minus, called hydrogen sulfide or bisulfate. It's not important much, but one should know. Likewise, you must know this one, phosphate. Phosphate, PO4 3 minus, and it came from this acid, H3, 3 protons, PO4. So H3PO4, phosphoric acid, phosphorus, phosphoric acid. And once you remove 3 protons, you get a PO4 3 minus called phosphate. Phosphate ions is present lots of it in our body. And if you remember the beginning of our discussion, this phosphate is one of the components in our nucleotides, right? ATP, GTP, triphosphate, all those triphosphate, diphosphate, monophosphate, the phosphates are all there. So that's why you should know the phosphate. Phosphate is 3 minus, PO4 3 minus, phosphate ion. If you remove only 2 hydrogen, you get HPO4 2 minus, hydrogen phosphate. If you remove 1 hydrogen, you get the H2PO4 dihydrogen phosphate. So basically, it's coming from the phosphate ion. So these ions you must remember. You have to. I usually don't give this one, okay? So whenever I ask the compound, what is the formula of ammonium phosphate? You should be able to do that, and I'll show you how we do that, right? All right. So let's go to now. We'll make it a compound. Any compound. I'm going to move on, okay? All right. So polyatomic anion, as I told you earlier, ammonium ion is the only one from ammonia. That's the origin of the polyatomic anion. Polyatomic anions, like origins, are mostly acids. All those things I already gave you the acid. Only one from the bases. That's a hydroxide ion, OH minus. And definition and properties, application of acid and base, we'll discuss later. All right. So this is just origins. I already told you earlier. Now, how to make the ionic compound?
Can you go back for like 1 second?
Sure. So the origin of the polyatomic anions, I gave you ammonium. You remember, ammonium is 3 plus proton, ammonium ion. That's a polyatomic cation, only one. Polyatomic anions are many, as you saw the list. One came from bases, that's a sodium the hydroxide, OH minus. And rest of them came from corresponding acids, nitrous acid, nitric acid, sulfuric acid, phosphoric acid, carbonic acid, all those acids, right? And that's basically those polyatomic anions that's the origin of the polyatomic anions. And we'll talk about the acids and bases down the road very soon. Just hang in there, huh? All right, so that's basically the origin of polyatomic anions. I'm going to move on, is okay? All right.
Yeah.
All right, so now how to derive the molecular formula? A general molecular formula, the general formula of any compound is written like this. Please write it down, right? Or you are doing it. M is the metal. Lowercase m is basically it's a number of negative charges, and you'll see how it's a crisscross. A is the anion, N is the number of cations, number of positive charges like cations. So M, capital M, lowercase m, A, anion, N. That's because the molecule as it is a neutral. So A is the anion, M is the cation, is the metal. So when N equal 1 is a group 1 elements. Group 1 elements. So basically group 2 elements N equal 2, group 3 elements N equal 3. M equal 1 when 7 elements. M equal 1 so 7 elements. And because 8 minus 7 is 1, so M equals 7 elements. 8 minus 2, group 6, 8 minus 6 is 2. So M equal 2 and M equal 3 when is the group 5A elements. And overall charge of the molecule when you make the ionic compound must be 0. That means total number of positive charges and total number of negative charges must be equal. All right. Now I'm going to the whiteboard to make some compounds. Everybody is there? All right. Just to show you how we make the ionic compounds, I'll take the example of a group 1A. I think we did some, but let me see. I think I might have the next slide. Next slide is this one. The formula of ionic compound. So when N equal 1, group 1A elements, right? So hydrogen become H plus. It's not a metal. We're just writing it as a group 1A. Lithium will lose 1 electrons, become 1 plus. Sodium will lose 1 electrons, become sodium plus. Potassium will lose 1 electron, become 1 potassium plus. And you know why. I will give the sodium example. And they follow the octet rule. Sodium, potassium follow the octet rule. Lithium follow the helium rule because it doesn't have 8 electrons to begin with, right? So remember the lithium is 3 electrons. So once 1 electron is lost, it becomes 2 electrons, and that's the helium configuration. So it is stabilized. So group 1A elements, 1 electrons become this. Now if you have a M equal 1, that's a group 7A elements, fluorine, chlorine, bromine, iodine. They will take 1 electrons each. The electron lost by the sodium, potassium, or lithium. They'll become F minus, Cl minus, Br minus, and I minus, etc. Now, if you combine them together, for example, let's say if you have a lithium, for example, so lithium is a plus, and then if you take X minus, so X equal our fluorine, for example, fluorine, right? Fluorine, chlorine, bromine in general, and iodine, I. These are our halogens. So if you take the X plus, lithium plus, and X minus, X is the fluorine, chlorine, and bromine, iodine. So now if you want to make a compound, 1 plus, 1 minus. So what will happen? You'll have a lithium X. So now if X is a fluorine, so what will be the name? Can someone tell me? If X is the fluorine, F, then what's the name of this compound? When X equal F, what's the name of the compound? Yes? It's a lithium
chloride.
Lithium fluoride. If X is a Cl, lithium chloride. X is a Br, lithium bromide. If X is I, lithium iodide. Likewise, instead of lithium, if it is sodium, tell me what's the name of this sodium X. So when X equal I, what's the name of that? What's the name of NaI? NaI. What's the name of NaI? Sodium iodide.
Sodium iodide.
Yeah, absolutely right. Just a minute. Yes. Likewise, if you have a Kx, let's say X is F, fluorine. So name will be potassium fluoride. That is right. Very good. Very good. So that's the basically you get. And if it is H plus, then you get the hydrogen fluoride. If the HI, hydrogen iodide. So sodium bromide, NaBr, KCl, potassium chloride, lithium bromide, cesium chloride, etc., etc. Right? So everybody okay, right? When you can do the molecular compound, you can make the ionic compound. Everybody okay so far? Can you do it? Yes, you can do it. So N equal 1, group 1 elements become 1 positive charge, group 7A elements become 1 negative charge. Together, they make a compound. We can make a sodium, potassium, iodine, lithium, potassium, sodium, rubidium, all those things, whatever we have a group 1 elements, and we can make a respective ionic compound. All right. So now we'll go to the group 2. Group 2. So when n equal 2, the group 2 elements, right? So magnesium, group 2a, lose 2 electrons, become 2 plus. And remember, the electronic configuration of a sodium magnesium 2 plus is 2s2 2p6, right? That's why it's doing it, fulfilling the octet rule, and by default become 2 positive charges. And those 2 electrons will be taken by somebody. We'll come back later, the anions or the non-metals. So group 2a, magnesium become 2 plus, calcium become 2 plus, strontium become 2 plus, barium become 2 plus. Group 2a, right? Now, when m equal 2, that's a group 6a elements. Oxygen, group 6a, it will take those 2 electrons, become 2 minus. Sulfur will take those 2 electrons, become 2 minus. Selenium, group 6, will take 2 electrons, become 2 minus. And you can go on like this way. Now, if we put them together, donor, acceptor. Metal is the donor, non-metal is acceptor. Donor, acceptor, let's put them together. You get the magnesium 2 plus, O 2 minus. Magnesium oxide, 2 plus 2 minus, neutral. And the name of this compound is magnesium oxide. Likewise, calcium 2 plus, sulfide 2 minus, together calcium sulfide, right? It's a neutral, 2 plus 2 minus. Barium 2 plus, oxygen 2 minus, barium oxide. Strontium 2 plus, sulfur 2 minus, sulfide 2 minus, strontium sulfide. And now you can make the compound like this, right? So everybody okay, right? Everybody following this one, how they're making the ionic compound? Similarly, we can go to group 3. When n equal 3, group 3 elements, aluminum become aluminum 3 plus, lose 3 electrons. Gallium will lose 3 electrons, will become 3 plus. Indium will lose 3 electrons, indium on 3 plus, etc. Right? 3a, 3 minus, 3 pluses. Those 3 electrons will be taken by somebody. Let's say if we take the m equal 3, group 5a elements, nitrogen is group 5 elements, so is the phosphorus, right? So is the phosphorus and arsenic. So let's go to this one, yes. So nitrogen N3 minus, phosphorus will take 3 electrons, phosphorus 3 minus. They're all following the octet rule, right? Arsenic will take the 3 electrons, arsenic 3 minus, arsenide down, phosphide down, nitride down. And now, if we put them together, 3 plus, 3 minus, 3 plus, 3 minus, 3 plus, 3 minus. The molecule as a whole is a neutral molecule. So aluminum 3 plus, nitrogen 3 minus, together aluminum nitride. Gallium 3 plus, phosphorus 3 minus, gallium phosphide. Indium 3 plus, arsenic 3 minus, indium arsenide. And it goes on like this way, very similar. So everybody okay, right? This is a common principle to make the ionic compound with group. Now you can make a crisscross. We can say group 1 elements and group 7 elements. Let's say group 6 elements. And let's see what happens then. Everybody okay, right? Shall I move on to the next? Yes. So when n equal 3, right? Group 3 elements and n equal 1, group 1 elements, so 7a, then we can write, or this is a little bit, I think we are going to, let's see, that's fine. That's fine. So basically, so we can take a like this way. Let's say lithium plus. I'm going to a little bit further, a little bit A, and then if we take the A to group 6A, and we can make a oxygen, right? Oxygen 2 minus. So group 1A and group 6A, and now we can make a compound is the lithium oxide. Now, lithium is 1 plus, oxygen is 2 minus. So you have to have a 2 lithium to neutralize. So Li2, or lithium oxide. Likewise, you can make a sodium, which is group, which is plus 1, right? Group 1A. And you can also make a compound with a sulfide, which is 2 minus. So 1 plus, 2 minus. So you have to get 2 of them. So you have a 2 sodium and 1 sulfur is sodium sulfide. Likewise, you can make the same thing with the potassium, arsenide, etc., etc. Potassium oxide, K2O, and so on like that. So this is group 1A and group 6A. Likewise, if you take the group 2A, right? Group 2A, group 2A, for example. Give me 1 second, please. So if you take a magnesium, and then if you take a fluorine minus, for example, fluorine minus. So fluorine minus is a group 2A, right? Magnesium is group 2A, so 2 plus and 2 minus. And then if you want to take a compound, yeah.
Class is over.
I know, I thought so. I know. All right, this is my last one then. So if you have a group 2 elements and group 7A, so in the homework, as a homework, please do it. I'm not going to grade it. So homework, do this one. Do the one that I already said you about group 2 metals and 7, 6, and 5. So make that one. And then one that we'll talk about from Wednesday as a group, this one. I'll continue, and then we'll continue from there. All right, very good. I'll see you Wednesday, okay? All right. Looks like we are being very, very short of time. All right, 50 minutes, not enough, huh? All right, if you have any question, I'm here. Just give me a second. Do you have any question on this slide or anything that you want to do? You have a question?